Hello students. So today we are going to start the fifth topic of your syllabus, that is laws of motion. Okay, so before going to the actual part, so first we should know the basics of this topic. That is the first one about the force. Okay, I heard the word force. Obviously you have to hear the force. So whenever you are learning the physics, okay, what's the force? Okay, see here I'll give some example. Suppose there is a body which is at rest on a particular surface. Okay, I want to move that body. We want to move that body, so that we should apply some external agency. Okay, suppose the body is already under motion. Suppose the body is already under motion and we want to stop its motion. So we should give an external agent so that it can stop the moving body. For example, and one more thing, suppose the body is moving in a particular direction. I want to change its direction. Again, we need to have an external agency. Okay, so this external agent is called the force. Okay, then how to define the force? So force is an external agent that causes motion in a rest body. Actually ಇದೆಲ್ಲಿತ್ತು ರೆಸ್ಟ್ ಆಗಿತ್ತು, ನೀವು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ ತಕ್ಷಣ ಮೂವ್ ಆಗ್ಲಾಕ್ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತು. ಸೊ ದ್ಯಾಟ್ ಕಾಸಸ್ ಮೋಷನ್ ಇನ್ ಅ ರೆಸ್ಟ್ ಬಾಡಿ, ಆರ್ that stops the moving body, or that changes the direction of motion. So the external agent which causes motion in a rest body, or the external agent which stops the moving body, or the external agent which changes the direction of motion, so that external agent is called the force. Okay, so how to define the force? So force is an external agent, or you can say force is an external agent that causes motion in a rest body, or stops the moving body, or changes the direction of motion. So ಈ ಮೂರು ಕೆಲಸ ಮಾಡೋ ಅಂತ ಎಕ್ಸ್ಟರ್ನಲ್ ಏಜೆಂಟ್ಗೆ ಏನಂತ ಕರಿತೇವೆ ನಾವು? ಫೋರ್ಸ್ ಅಂತೇವ. ಸರಿನಾ? ಓಕೆ, ಆ್ಯಂಡ್ SI unit of force. So as per the Newton's second law, we can write F equal to m into A. So as per this one, the unit is kg meter per second square. M mass, kg, acceleration, meter per second square. So combining these three, so we give the name as the n. This is the symbol. So SI unit of force is Newton. If you want to write the unit in full form, you should start with a small letter. If you want to write it in symbolically, you should use the capital N. Okay, and the dimensional formula. So this is, okay, for m you have to write the m mass, and for acceleration this is 1 dimension in length and minus 2 dimension in time. So this is ml t to the power minus 2 is the dimensional formula for the force. And next is about the laws of motion, that is Newton laws of motion. And you have studied in your previous classes, there are three laws of motion predicted by the Newton. Okay, so what's the statement of the first law? So that is Newton's first law. So any body continues in its state of rest or motion until it is compelled by an external force. So it's very simple. In meaning, ಯಾವುದೋ ಒಂದು ಆಬ್ಜೆಕ್ಟು ತನ್ನದೇ ಆದ ಒಂದು ಸ್ಥಿತಿನಲ್ಲಿ ಮುಂದುವರಿತಿರ್ತದ. ಎಲ್ಲಿ ತನ್ನ ತಂದೆ ಸ್ಥಿತಿಯಲ್ಲಿ ಇರ್ತದೆ ರೀ, ಎಲ್ಲಿವರೆಗೂ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಆಗಂಗಿಲ್ವೋ ಅಲ್ಲಿ ತನಕ. Okay, unless it is compelled by an external force. So external force ದಿಂದ ಅದು ಕಂಪೆಲ್ ಆಗಲಿಲ್ಲ, ಓಕೆ, ಡಿಸ್ಟರ್ಬ್ ಆಗಲಿಲ್ಲ, ಅಲ್ಲಿ ತನಕ ಅನ್ನೋದು ತನ್ನದೇ ಸ್ಟೇಟಲ್ಲಿ ಮೂವ್ ಆಗ್ತಿರ್ತದ. ಸೊ ದ್ಯಾಟ್ ಸ್ಟೇಟ್ ಮೇ ಬಿ ಯೂನಿಫಾರ್ಮ್ ಮೋಷನ್, ಆರ್ ಇಟ್ ಮೇ ಬಿ ದ ರೆಸ್ಟ್. ಸೊ ದಿಸ್ ಇಸ್ ನ್ಯೂಟನ್ಸ್ ಫಸ್ಟ್ ಲಾ. ಸೊ ನಿಮ್ಗೆ ಸಿಲೆಬಸ್ ಕೊಟ್ಟಿದ್ದಾರಲ್ಲ, ಈಗ ಸ್ವಲ್ಪ ಡಿಡಕ್ಟ್ ಮಾಡಿ ಸಿಲೆಬಸ್, ಅದರ ಪ್ರಕಾರ ನ್ಯೂಟನ್ಸ್ ಲಾಸ್ ಇನ್ ಎಕ್ಸಾಮ್ ನಿಮ್ಗೆ ಬರೋದಿಲ್ಲ. ಬಟ್ ಇವು ಗೊತ್ತಿಲ್ಲ ಅಂದರೆ ಮುಂದಿಂದ ಕಲಿಯೋದು ಸ್ವಲ್ಪ ಡಿಫಿಕಲ್ಟ್ ಆಗ್ತದೆ. ಐ ಆಮ್ ಜಸ್ಟ್ ರಿಫ್ರೆಶಿಂಗ್ ದ ಥಿಂಗ್ಸ್ about the Newton laws and some important concepts which are studied in your previous classes. Okay, so any body continues in state of rest or uniform motion until it is compelled by an external force. ಯಾವುದೋ ಒಂದು ಬಾಡಿ ತನ್ನದೇ ಆದಂಥ ಒಂದು ಮೋಷನಲ್ಲಿ ಹೋಗ್ತಿರ್ತದೆ, ಯೂನಿಫಾರ್ಮ್ ಮೋಷನಲ್ಲಿ ಅಥವಾ ರೆಸ್ಟ್ ಸ್ಟೇಟಲ್ಲಿ ಇರ್ತದೆ. ಸಪೋಸ್ ದ ಬಾಡಿ ಇಸ್ ಅಟ್ ರೆಸ್ಟ್, ಇಟ್ ವಿಲ್ ಬಿ ಆಲ್ವೇಸ್ ಅಟ್ ರೆಸ್ಟ್ ಅನ್ಲೆಸ್ ಆ್ಯಂಡ್ ಅಂಟಿಲ್ ಇಟ್ ಈಸ್ ಕಂಪೆಲ್ಡ್ ಬೈ ದ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್. ಬೇರೆ ಫೋರ್ಸ್ ಬಂದು ನೀವು ಅದಕ್ಕೆ ಅಪ್ಲೈ ಮಾಡೋ ತನಕ ಅದು ತನ್ನದೇ ಆದ ರೆಸ್ಟ್ ಸ್ಟೇಟ್ದಾಗ ಇರ್ತದೆ. ಸಪೋಸ್ ಆಬ್ಜೆಕ್ಟ್ ಈಸ್ ಮೂವಿಂಗ್ ಇನ್ ಯೂನಿಫಾರ್ಮ್ ಮೋಷನ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಒನ್, ಯು ಶುಡ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಟರ್ಮ್ ಲೀನಿಯರ್ ಮೊಮೆಂಟಮ್. ಸೊ ಲೀನಿಯರ್ momentum, so its symbol is P. So what is the linear momentum? So we can write mathematically as P is equal to mass into velocity. Okay, so if I asked define the linear momentum, you can easily say it's a product of mass of a body and its velocity. It's a linear momentum is a product of mass of a body and its velocity. Okay, it's a mathematical form, you may get a marks. But what is the exact meaning of the linear momentum? What's the exact meaning of linear momentum? So, linear momentum is the strength of motion that measures the strength of motion. So, what's the strength of that moving body? Okay, for example, okay, on the example ತಗೊಂಡು discussion ಮಾಡೋಣ ಇವಾಗ. So, there is an object. So, there is an object like a small m. Okay, ಒಂದು stone ಅದ ಅಂತ ಅಂದ್ಕೊಳ್ರಿ. ಒಂದು stone ಅದ. Okay, so it is having the mass m. It is having the mass m, or you can say it is of about 10 gram. It is of about 10 gram. So ಮತ್ತೊಂದು ಬಾಡಿ ಅದ, it is of about 2 kg. It is of about 2 kg. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ಏನು ಅಂದ್ಕೊಂಡ್ರಿ ಇವಾಗ ಇಬ್ಬರು ಮನುಷ್ಯರು ಹಿಂಗೆ ನಿಂತಿದ್ದಾರೆ ಇಲ್ಲಿ, ಅಥವಾ ಇದು ಒಬ್ಬ ಮನುಷ್ಯ ನಿಂತಿದ್ದಾನ. ಓಕೆ, ಇವನ ಮೇಲೆ ಏನು ಮಾಡೋಣ, ಸ್ವಲ್ಪ ಹೈಟ್ದಿಂದ ಈ 10 ಗ್ರಾಮ್ ಸ್ಟೋನ್ ಅನ್ನೋದ ಏನು ಮಾಡೋ ಬಿಟ್ಬಿಡೋಣ್ರಿ, ಅವ್ನ ತಲೆ ಮೇಲೆ ಬೀಳ್ತದ. ಹೌದಾ, ಏನು ಸರ್ 10 ಗ್ರಾಮ್ ಒಂದು ಚಾಕ್ ಪೀಸ್ ಅಷ್ಟು ವೇಟ್. ಸೊ ಇದು ನಮ್ಮ ತಲೆ ಮೇಲೆ ಬಿದ್ದರೆ ಏನು ಫರ್ಕ್ ಆಗಿಲ್ಲ, ಏನೋ ಆಗಿದೆ ಅಂತ ಗೊತ್ತಾಗ್ತದ, ಬಟ್ ಇಟ್ ಡಸಂಟ್ ಅಫೆಕ್ಟ್ ಅಸ್. ಸೊ ನಮಗೇನೋ ಅದು ನೋವು ಮಾಡೋಂಗಿಲ್ಲ. ಹೌದಾ, ಓಕೆ. ಸೊ ದ ಸೇಮ್ ಥಿಂಗ್ ಇಫ್ ಯು ಅಲೌ ದ ಲಾರ್ಜ್ ಸ್ಟೋನ್ ಟು ಫಾಲ್ ಆನ್ ದ ಸೇಮ್ ಬಾಡಿ. ಸೊ ಆ ಮನುಷ್ಯನ ಮೇಲೆ ಇದು ಲಾರ್ಜರ್ ಇದು ಬಿಟ್ವಿ ಅಂತ ತಿಳ್ಕೊಳ್ರಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇಟ್ ಈಸ್ ಮೂವಿಂಗ್ ವಿತ್, ಸೊ ನಾವೇನು ಮಾಡೋಣ ಇವಾಗ, ಇಟ್ ಈಸ್ ಮೂವಿಂಗ್ ವಿತ್ 10 meter per second and this is also moving with 10 meter per second, for example. Or you can throw that body. ಸೊ ಇಲ್ಲಿ 10 ಗ್ರಾಮ್ದು ಒಂದು ಬಾಡಿ ಅದ, ಆಮೇಲೆ 2 kg ಒಂದು ಬಾಡಿ ಅದ, ಇಲ್ಲೊಬ್ಬ ಮನುಷ್ಯ ನಿಂತ್ಕೊಂಡಿದ್ದಾನೆ, ಅಥವಾ ಇನ್ನೂ ಒಂದು ವಾಲ್ ಅದ, ಗ್ಲಾಸ್ ಟೈಪ್ ಅದ. ಸೊ ಇಫ್ ಯು allow this 10 gram body to move in 10 meter per second on that person, okay, what's the effect? So we can say ಒಂದು ಸ್ವಲ್ಪ ಹೊಡಿತದ್ರೆ ಕಲ್ಲ ನಿಂತ್ಕೊಂತದ. If you allow the 2 kg of body to move in 10 meter per second, so what's the effect on that person? ಸೊ ಡೆಫಿನೆಟ್ಲಿ ಇಲ್ಲಿ ಏನಾಗಿರ್ತದೆ, ಅವ್ನಿಗೆ ಭಾಳ ಪೆಟ್ಟು ಆಗ್ತದ, ಇಲ್ಲಿ ಏನಾಗಿರ್ತದೆ, ಕಡಿಮೆ ಪೆಟ್ಟು ಆಗ್ತದ. ಹೌದಾ, ಇದರ ಅರ್ಥ ಏನಾಯ್ತಾ, ಇವನ್ ದೋ ದ ಬಾಡೀಸ್ ಆರ್ ಮೂವಿಂಗ್ ವಿತ್ ದ ಸೇಮ್ ಸ್ಪೀಡ್, ಬಟ್ ದ ಮಾಸಸ್ ಆರ್ ಡಿಫ್ರೆಂಟ್. m1 and m2 masses are different. So as a mass change, the quantity of the motion changed. And I will give you one more example. So where you can keep the mass constant and velocity change. We are having a gun and we are firing the bullet. Okay, so and we are having a bullet separately. ಗನ್ ದಾಗ ಇರ್ಲಾರ್ದೆ ಒಂದು ಬುಲೆಟ್ ಅದ, ಗನ್ದಾಗ ಒಂದು ಬುಲೆಟ್ ಅದ ರೀ, ಸರಿನಾ? ಸೊ ಇವಾಗ ಏನಾದರೂ ಗನ್ನಿಂದ ಬುಲೆಟ್ ನೀವು ಫೈರ್ ಮಾಡಿದ್ರ, ಇಲ್ಲೊಂದು ಹಿಂಗೆ ಸ್ಕ್ರೀನ್ ಅದ, ಒಂದು ವಾಲ್ ಅದ ಅಂತ ಅಂದ್ಕೊಂಡು ಫೈಬರ್ ಅದ, ನೀವು ಬುಲೆಟ್ ಫೈರ್ ಮಾಡಿದಂದರೆ ಇಲ್ಲಿ ಸಿಳ್ಕೊಂಡು ಹೋಗಿಬಿಡ್ತದೆ ರೀ, ಇಲ್ಲಿ ನಿಮ್ಗೆ ಹೋಲ್ ಫಾರ್ಮ್ ಆಗ್ತದೆ. ಹೌದಾ, ಸೊ ದ್ಯಾಟ್ ಗಿವ್ಸ್ ದ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ದ ಮೋಷನ್ ಆಫ್ ದ್ಯಾಟ್ ಬುಲೆಟ್. ಸೊ ಇಟ್ ಮೇ ಮೂವಿಂಗ್ ವಿತ್ ಅ ವೆರಿ ಹೈ ಸ್ಪೀಡ್. Okay, I am using the same bullet. I am just throwing that bullet by my hand. Can I give the same speed as that of by the gun? ಗನ್ನಿಂದ ಕಷ್ಟದ ಸೇಮ್ ಸ್ಪೀಡ್ ಕೊಡೋಕ್ಕಾಗ್ತದೆ? ನೋ. ಅವಾಗ ಏನಾಗ್ತದೆ, ಇಲ್ಲಿ ಹೋಗ್ತದೆ, ಇಲ್ಲಿ ಹೊಡೆದ್ಬಿಟ್ಟು ವಾಪಸ್ ಇಲ್ಲಿ ಬೀಳ್ತದೆ ಬುಲೆಟ್, ಯಾಕಂದರೆ ಸಿಳ್ಕೊಂಡು ಹೋಗಂಗಿಲ್ಲ. ಓಕೆ, ಸಿ ಹಿಯರ್ ಇನ್ ಬೋತ್ ದ ಕೇಸ್ ಐ ಆಮ್ ಯೂಸಿಂಗ್ ದ ಸೇಮ್ ಬಾಡಿ. Okay, having the mass m here also and m here also, but here the effect is different and here the effect is different. So because the effect is different, because the velocity is different. Is it clear? So the quantity of motion not only depending on the velocity, it also depending on mass. Okay, so the quantity of motion or the strength of motion is explained by the combined is explained by both its mass and velocity. So that's why we should combine them to measure the strength of motion. So that combined physical quantity is called the linear momentum. Is it clear? What's the linear momentum? Linear momentum is a product of mass and velocity of the body. Is it okay? And what's the SI unit of linear momentum? So as per the formula, so P is equal to m into V. So for the mass we will write kg, for velocity we will write meter per second. Okay, so the SI unit of linear momentum is kg meter per second. Okay, what's the dimension formula? So for the P, so for mass we will write m, for the velocity we will write L t to the power minus 1. L t to the power minus 1. This is the dimension formula for the linear momentum. Is clear? Okay, and one more thing, linear momentum is it scalar or vector? Already I have mentioned the formula. So that is in vector notation. That's why the linear momentum is in vector. Okay, is a vector quantity. See here, the linear momentum is depending on the velocity. Okay, and velocity is a vector quantity and mass is a scalar. So whenever a scalar is multiplied by a vector, then the result will be a vector quantity. So that's why we say the linear momentum is a vector quantity. Is a vector quantity. Okay, so this is about the basic idea of linear momentum. Okay, if you know this one, we can go for Newton's second law of motion. Newton's second law of motion. Okay, see here. So what is Newton's second law? The rate of change of linear momentum of a body is directly proportional to the force. The rate of change of linear momentum of a body is directly proportional to the force. Okay, so I can write the force is directly proportional to rate of ಅಂದ್ರೆ ಏನು divided term ಯಾವಾಗಲೂ time ಇರ್ತದ per second ಅಂತ ಯಾವುದೋ ಕ್ವಾಂಟಿಟಿ ಮೆಜರ್ ಮಾಡ್ಲತ್ತಿದ್ರೆ if you are measuring any quantity per second then we say that as the rate of. Okay, so the rate of what in by dp. So dp means p2 minus p1. p2 minus p1, this is called the change in. Okay, divided by time ಬರ್ತದೆ ಅಂದ್ರೆ ಅದೇನಿದು the rate of change of linear momentum. The rate of change of linear momentum is directly proportional to the force, applied force. Okay, so F equal to d by dt of linear momentum, d by dt of linear momentum time rate of and change of linear momentum. Okay, so then I want to remove the proportion sign. I have written the k. So F equal to k into dp by dt. Okay, so F equal to dp by dt. Okay, what's the p value? P is mv. Is it? Okay, and here d by dt of mass is a constant thing. Mass is a constant term, it doesn't vary. So the mass of body is same, and here the v as the differentiation. Okay, d by dt, differentiation of velocity is nothing but acceleration. So we will get F equal to m into a. So which is the formula for the mechanical force. Is it? So what's the formula for the force? Force is equal to m into a. How we can derive the formula of that mechanical force? By using the Newton's second law of motion. What's Newton's second law of motion? The rate of change of linear momentum of a body is directly proportional to the applied force. Is it? Okay. And next one, Newton's third law. So you people are very familiar with this law, and which is very simple. Okay, another Newton's third law. For every action there is an equal and opposite reaction. So ಪ್ರತಿಯೊಂದು ಆ್ಯಕ್ಷನ್ಗೂ ಏನಿರ್ತದ ಅಲ್ಲೊಂದು ರಿಯಾಕ್ಷನ್ ಇದ್ದೇ ಇರ್ತದ. ಆಮೇಲೆ ಆ ರಿಯಾಕ್ಷನ್ನು ಯಾವಾಗಲೂ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ದಾಗಿರ್ತದ ಮತ್ತು ಈಕ್ವಲ್ ಇರ್ತದ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಾ ಈಗ ಏನಾದರೂ ಹಿಂಗೆ ಹಿಟ್ ಮಾಡಿದೆ ಅಂತ ಹೇಳಿದೆ, ಹಿಂಗೆ ಈ ಬೋರ್ಡಿಗೆ ಹಿಂಗೆ ಹೊಡೆದ್ನ. ಸೊ ಏನಾಯ್ತಾ, ಐ ಆಮ್ ಅಪ್ಲೈಯಿಂಗ್ ಫೋರ್ಸ್ ಆನ್ ದ ಬಾಡಿ. At the same time the body is opposing me. At the same time body is giving some force. So e force these two forces are equal in magnitude. ಇಲ್ಲಿಂದ ಎಷ್ಟು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ನಲ್ಲ ಅಲ್ಲಿಂದ ಅಷ್ಟ ಫೋರ್ಸ್ ಬರ್ಲಾತದ. Okay, equal in magnitude, but what are the direction? I am applying in this direction force. At the same time the body is giving me an opposing force. Okay, so these two forces are equal and opposite. Clear? So as per the Newton's third law, I can write the action is equal and opposite to the reaction. Action and reactions are always equal and opposite. So this is the Newton's third law of motion. And the next point is about the impulse. See the headline, impulse. Okay, so what by impulse? I'll give an example. So later I can explain what is the impulse. So ನಾವೆಲ್ಲರೂ ಕ್ರಿಕೆಟ್ ಆಡ್ತಿರ್ತೇವ. ಸೊ ಕ್ರಿಕೆಟಲ್ಲಿ ಏನಾಗ್ತದ, ವಿ ಹಿಟ್ ದ ಬಾಲ್ ಬೈ ದ ಬ್ಯಾಟ್. ಸೊ ಬ್ಯಾಟಿಂದ ಏನು ಮಾಡಿರ್ತೇವ, ಓಕೆ, ಬಾಲ್ನ ಹಿಂಗೆ ಹಿಟ್ ಮಾಡಿರ್ತೇವ. ಓಕೆ, ಆಮೇಲೆ ಏನಾಯ್ತಾ, ಈ ಬ್ಯಾಟು ಈ ಬಾಲ್ ಮೇಲೆ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿರ್ತದ. ಈ ಬ್ಯಾಟು ಮತ್ತು ಬಾಲ್ ಮೇಲೆ ಫೋರ್ಸ್ ಮಾಡಿರ್ತದ. ಆ್ಯಂಡ್ ವಿ ಸೇ ದಿಸ್ ಇಸ್ ದ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್. ಓಕೆ, ಆ್ಯಂಡ್ ಸಿ ದಟ್ ಫೋರ್ಸ್ ಆ್ಯಕ್ಟ್ಸ್ ಫಾರ್ ಅ very small time interval. That force acts on the body at a very small interval. ಸೊ ಇಲ್ಲಿ ಇವಾಗ ಫೋರ್ಸ್ ಎಷ್ಟು ಅಪ್ಲೈ ಆಯಿತು, ಎಷ್ಟೊತ್ತು ಅಪ್ಲೈ ಆಯಿತು ಅಂತ ನಾವು ಇಂಡಿವಿಜುವಲಾಗಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ಭಾಳ ಡಿಫಿಕಲ್ಟ್ ಆಗ್ತದೆ. ಹೌ ಮಚ್ ಫೋರ್ಸ್ ಇಸ್ ಅಪ್ಲೈಡ್ ಆನ್ ದ ಬಾಲ್ ಬೈ ದ ಬ್ಯಾಟ್ ಆ್ಯಂಡ್ ಹೌ ಮಚ್ ಟೈಮ್ ಇಂಟರ್ವಲ್ ಇಟ್ ಹ್ಯಾಸ್ ಟೇಕನ್, ಹೌ ಲಾಂಗ್ ಇಟ್ ಈಸ್ ಅಪ್ಲೈಡ್, ಎಷ್ಟೋ ತನಕ ಆ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಆಯಿತು, ಆಮೇಲೆ ಎಷ್ಟು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಆಯಿತು. ಸೊ ಈ ಥರ ಟೈಮ್ ಮತ್ತು ಫೋರ್ಸ್ ಸಪ್ರೇಟಾಗಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ಇದು ಭಾಳ ಡಿಫಿಕಲ್ಟ್ ಆಗ್ತದೆ. ಬಿಕಾಸ್ ಇಟ್ ಹ್ಯಾಪನ್ಸ್ ವಿದಿನ್ ಅ ಫ್ರ್ಯಾಕ್ಷನ್ ಆಫ್ ಸೆಕೆಂಡ್. ಗೊತ್ತಾಗ್ತದಾ? ಸೊ ಇನ್ ಸಚ್ ಕೇಸಸ್ we introduce the new quantity which is called impulse. And what is the impulse? So impulse is the product of force and time. So whenever a large force, whenever the force acts on a body within a small interval of time, then the product of force and time is called a new quantity, impulse. The product of force and time is called the impulse. Okay, and see if you want to get the impulse, and in some books they have written it as impulsive force. You call it as impulsive force. Okay, impulse or impulsive force. Okay, what is the impulsive force or impulse? So it is a force acting on a body for short interval of time. So where you can't get how long it has applied. Okay, so in such a cases we calculate the amount of impulse acted on that body. Instead of finding the force acting on a body, we find the impulse acted on that body. Okay, so how to get the impulse? So that is J is equal to force into the small interval of time, that is delta t. And see, force is a vector quantity, that's why this J, the symbol of impulse is J. So J is equal to force into small interval of time. Is it clear? Okay, and we know the second law of motion, Newton's second law of motion, that is dp by dt is equal to force. Is it? Then dp is equal to f into dt, or we will write delta p by delta t. Okay, so this is change in linear momentum divided by change in time is equal to force. So then delta p is equal to f into delta t. Is it? Okay, so f into delta t, if I write all the quantities in vector notations, so delta p by delta t, okay, is equal to force. Then delta p is equal to force into the time. So what is delta p? Change in linear momentum. So I can write is final linear momentum minus initial linear momentum is equal to force into delta t. What is the force into delta t? Force into delta t is our impulse. So I will write the symbol delta t. Sorry, that is J. And here this is P2 minus P1. Okay, in words what you can write? What is the P2 minus P1? I can write change in linear momentum of a body is equal to impulse. Is a very important result. So what is the impulse? The change in linear momentum of a same body. So on body nalli initial linear momentum estitu, final linear momentum into anta find out madri. Final linear momentum minus initial linear momentum, it will give you the impulse. Okay, so what is the impulse? Is the force acting on a body, the quantity of force acted on a body for a short interval of time. ಒಂದು ಸ್ಮಾಲ್ ಟೈಮ್ದಾಗ ಫೋರ್ಸ್ ಎಷ್ಟು ಅದಕ್ಕೆ ಅಪ್ಲೈ ಆಯ್ತಾ ಇದು ಮೆಜರ್ ಮಾಡೋದು ಏನಾಗ್ತದ ಇಂಪಲ್ಸ್ ಆರ್ ಇಂಪಲ್ಸಿವ್ ಫೋರ್ಸ್. ಹೌ ಟು ಗೆಟ್ ದ ಇಂಪಲ್ಸಿವ್ ಫೋರ್ಸ್ ಇಸ್ ಅ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ದ ಫೋರ್ಸ್ ಆನ್ ಅ ಬಾಡಿ ಆ್ಯಂಡ್ ದ ಟೈಮ್ ಇಂಟರ್ವಲ್. Okay, and the easiest way to get the impulse is you measure its momentum, final momentum, initial momentum, and final minus initial, so that will give the impulse. Okay, and the next one is law of conservation of linear momentum. So conservation andre ಏನು, it is preserved. Okay, or you can say it is, ನೀವು ಸಿಂಪಲ್ ವರ್ಡ್ಸ್ ಅಲ್ಲಿ ಅನ್ಕೊಳ್ರಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರ್ತದ ಅನ್ನಂಗೆ. ಕನ್ಸರ್ವೇಷನ್ ಅಂದರೆ ಸಂರಕ್ಷಿತ ಅಂತ, ಸಂರಕ್ಷಣೆ. ಓಕೆ, ಸೊ ಲಾ ಆಫ್ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಲೀನಿಯರ್ ಮೊಮೆಂಟಮ್. ಓಕೆ, ಸೊ ವಾಸ್ ಅ ಲಾ ಆಫ್ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಲೀನಿಯರ್ ಮೊಮೆಂಟಮ್? ಸೊ the statement, you may get a 5 marks question like a state and prove law of conservation of linear momentum. So which is important for 5 marks, state and prove law of conservation of linear momentum. Okay, so the linear momentum of an isolated system, is always constant. So this is the statement of law of conservation of linear momentum. So ಯಾವುದಾದ್ರೂ ಒಂದು ಸಿಸ್ಟಮ್ ತೊಗೊಂಡ್ರೆ ಅಂದರೆ ಲಾ ಆಫ್ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ linear momentum of an isolated system is always of a system of an interacting particles. Okay, so of interacting particles Okay, so for an interacting particle, the linear momentum of a system is always a constant. The linear momentum of an isolated system is always a constant. So this is the statement. Okay, so how to prove this one? See here, we know F is equal to dp divided by dt. F is equal to dp by dt. Okay, so when it is constant, that is a condition. The linear momentum of isolated system is constant if no force acts on it. ಓಕೆ, ಸೊ ಸಪೋಸ್ ಏನಾದರೂ ಆ ಬಾಡಿ ಮೇಲೆ ಟೋಟಲ್ ಫೋರ್ಸ್ 0 ಇತ್ತಂದರೆ ಆ ಬಾಡಿನಲ್ಲಿ ಲೀನಿಯರ್ ಮೊಮೆಂಟಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರ್ತದೆ. there is no change in the linear momentum. Okay, F is equal to dp by dt. If I say F is equal to 0, then dp divided by dt is equal to 0. Then dp is equal to 0. Okay, I take this d. Okay, dp is equal to 0. Then you can write p2 minus p1 is equal to 0. So p2 minus p1 equal to 0 means p2 is equal to p1. Okay, so p2 is equal to p1. So this is the linear momentum of the system before the collision and after the collision. Is it clear? Okay, so collision ಅಷ್ಟೇ ಅಲ್ಲ, so the initial linear momentum and the final linear momentum of a system is constant. So there is no change in the linear momentum. So this is the statement. Okay, so how to write or what to write as a statement? So you can write statement. The linear momentum of an isolated system is always constant if no force acts on it. No external force. We use the word no external force. No external force acts on it. No external force acts on it. This is our statement. Okay, and we can prove this. Proof of conservation of conservation of linear momentum in case of collision. In case of collision of two bodies. In case of collision of two bodies. Okay, see here, there are two bodies called A body and B body. A body is having the linear momentum PA. A body is having the linear momentum PA and B body is having the linear momentum PB, and they are moving. So I say its velocity is u1, its velocity is u2. Okay, and there is a condition, u1 is greater than u2. u1 is greater than u2. So here, so A and B are moving in a straight line, right? So A is moving with the u1 velocity, B is moving with u2 velocity. It's a linear momentum. This is m into ua, and here this is m into u2, right? And it is greater, it is moving with a higher speed, it is moving with lower speed. So if so, is slow untadre idinda fast baratada. After some time the body A collides with the body B. ಸೊ ಎ ಮತ್ತು ಬಿ ಎರಡು ಏನಾಗ್ತಾವ, ಕೊಲೈಡ್ ಆಗೋದಂದ್ರೆ ಏನು, ಎರಡು ಡಿಕ್ಕಿ ಹೊಡಿತಾವ, ಎರಡು ಒಂದಕ್ಕೊಂದು ಏನಾಗ್ತಾವ, ಡಿಕ್ಕಿ ಹೊಡಿತಾವ. ಓಕೆ, ಸೊ ಅದಾದಮೇಲೆ ಅದಾದಮೇಲೆ ಎ ದ linear momentum of A is changed to PA dash. Its velocity is V1. Okay, and B is moving with the velocity V2. Its linear momentum changes to PB dash. Okay, see here initially, and I can say this is before collision. Idu during collision. Okay, this is after collision. Okay, so before collision those two bodies were having the linear momentum PA and the body B is having the linear momentum PB. Okay, so when they collide and see during the collision there will be a short interval of time. There is a fraction of time. Collide ಆಗಸ್ಟ್ ಇಲ್ಲಿಂದ ಫಾಸ್ಟ್ ಆಗಿ ಬಾಡಿ ಬರ್ಲಾತಿದ್ದು ಸ್ಲೋ ಹೊಂಟಿದ್ರಿ, ಹಿಂಗೆ ಕೊಲೈಡ್ ಆಯಿತು, ಕೊಲೈಡ್ ಆದ ತಕ್ಷಣ ಇದು ಫಾಸ್ಟ್ ಮತ್ತು ಹೋಯ್ತು, ಇದು ಹೋಯ್ತು ಹಿಂಗೆ. ಸೊ ಲೈಕ್ ದಿಸ್ ದ ಟೈಮ್ ಇಂಟರ್ವಲ್ ಡ್ಯೂರಿಂಗ್ ದ collision is very small. And this is after the collision it started to move with the velocity v. Initially its velocity was u1, now its velocity changed to v1. Initially its velocity is u2, now it's changed to v2. So if the velocity are changing means m into v, the linear momentum changes. PA linear momentum before collision, PA dash linear momentum after the collision of the body A. Okay, and was a PB linear momentum of the body B before the collision. PB dash linear momentum of the body after the collision. ಗೊತ್ತಾಗ್ತದೆ? Okay, And how to calculate the change in linear momentum? Change in linear momentum of body A is, change in linear momentum of a body A is, alright, this is delta P of A. Okay, so this is final linear momentum minus initial linear momentum. This is P2, sorry. So what I have given the symbol, this is PA dash after the collision minus before the collision. Was it before the collision? This is PA. Okay, in the same way, change in linear momentum of a body B is, change in linear momentum of a body B is, I'll write delta PB is equal to linear momentum after the collision, that is PB dash, linear momentum before the collision, that is PB. Gottagtada? Okay, so then as per Newton's second law, of motion, we know force is equal to change in linear momentum divided by time, or you can write dp by delta p by delta t, change in linear momentum divided by time. Is it? Okay, so if I write it like f of AB, what by f of AB? The force on A body due to B. So this is equal to, the force on A body means how much force experienced by the body A, that is equal to change in linear momentum of A divided by the time interval, or I can write it as PA dash minus PA divided by delta T. Okay, in the same way I can write f of BA. So what is the f of BA? ಇಲ್ಲಿ ಹೆಂಗೆ ಓದಿದೀವಿ, ಫೋರ್ಸ್ ಆನ್ ಎ ಡ್ಯೂ ಟು ದ ಬಿ. ಬಿ ದಿಂದ ಎರಡು ಬಾಡಿ ಇಲ್ಲಿದಾವ, ಈ ಎ ಮೇಲೆ ಹೆಂಗೆ ಆಯ್ತಾ, ಸೊ ಇಫ್ ಎ ಕೊಲೈಡ್ ವಿತ್ ಬಿ, okay, if A is acting on a force B, then B also acts a same force on A, right? So f of BA, the force on B is equal to the change in linear momentum of B divided by delta T. Okay, is equal to PB dash minus PB divided by delta T. And as per according to Newton's third law, for every action there is equal and opposite reaction. There is a body A and body B, they collide, means a force is acted on a B, at the same time the force is acted on A. So these two forces are equal and opposite. So that's why I can write f of AB is equal to f of BA, but with a negative notation. So negative sign indicating they are in opposite direction, and this equal sign indicating they are equal in magnitude. They are equal in magnitude and opposite in direction. Okay, substitute these values here. F of AB in banth namdu PA dash minus PA divided by delta T. Okay, what are the f of BA? This is minus sign as it is, and here I will write PB dash minus PB divided by delta T. Okay, and you may ask, so why I have taken delta T in both the side? Why I have taken the same delta T on both sides? Because E force A body B ಮೇಲೆ ಎಷ್ಟೋ ತನ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡೈತೋ ಅಷ್ಟೋ ತನಕ B ನು A ಮೇಲೆ ಅಪ್ಲೈ ಮಾಡಿದ. So the time interval during the collision is same. The force experienced by the A, the force experienced by the B is equal and opposite, and they experience the force in the same time. The contact time is same for A or B. Is it? Okay, now, so the delta T cancelled. Now this is PA dash minus PA is equal to, say minus outside other PB dash idenaita minus PB dash minus of minus plus this is PB. Okay, so then take this minus sign this side and this minus side to the right hand side, so that all the terms are in positive. So now this is PA dash plus, take the PB here, this become PB dash equal sign. Take this minus PA to the right hand side, the minus PA become plus PA here, PA plus PB and PB as it is. So this is the final expression. Do you know the meaning of this equation? So was a PA dash, so this is linear momentum of a body after the collision. Was a PB dash linear momentum of a body B after the collision. Okay, was a PA the linear momentum of the same body before the collision. PB linear momentum of the B body before the collision. So linear momentum of A body before collision is not equal to linear momentum of the A after the collision, and B is not equal to after the collision of B, but the total linear momentum of the system. ಸೊ ಈ ಸಿಸ್ಟಮಲ್ಲಿ ಏನಿದಾವ ಎರಡು ಪಾರ್ಟಿಕಲ್ಸ್ ಇದಾವ. ಯಾವ ಎರಡು ಪಾರ್ಟಿಕಲ್ಸ್? ಎ ಮತ್ತು ಬಿ ಅನ್ನೋ ಎರಡು ಪಾರ್ಟಿಕಲ್ಸ್ ಇದಾವ. ಈ ಪೂರಾ ಸಿಸ್ಟಮ್ದು ಬಿಫೋರ್ ಕೊಲಿಷನ್ನು, ಪೂರಾ ಸಿಸ್ಟಮ್ದ ಆಫ್ಟರ್ ಕೊಲಿಷನ್ನು ಲೀನಿಯರ್ ಮೂಮೆಂಟಮ್ ಏನಿದಾವ ಸೇಮ್ ಇದಾವ. ಸೊ ಇವಾಗ ನಾನು ಏನು ಬರ್ತೀನ, ಡ್ಯಾಶ್ ಅಂದರೆ ಯಾವಾಗ ಇದೆ ಲೀನಿಯರ್ ಮೂಮೆಂಟಮ್ ಆಫ್ ಸಿಸ್ಟಮ್. ಸೊ ಇಲ್ಲಿ ಎಷ್ಟು ಸಿಸ್ಟಮಲ್ಲಿ ಎಷ್ಟು ಪಾರ್ಟಿಕಲ್ಸ್? ಎ ಪಾರ್ಟಿಕಲ್, ಬಿ ಪಾರ್ಟಿಕಲ್. ಸಿಸ್ಟಮಲ್ಲಿ ಎಷ್ಟು ಪಾರ್ಟಿಕಲ್? ಎ ಆ್ಯಂಡ್ ಬಿ. ಸೊ ದ ಟೋಟಲ್ ಲೀನಿಯರ್ ಮೂಮೆಂಟಮ್ ಆಫ್ ದ ಸಿಸ್ಟಮ್ means you should add linear momentum of individual particles. Linear momentum of individual particles. Okay, so ಏನಾಯ್ತು ಇವಾಗ? linear momentum of the system before collision is linear momentum of first particle plus linear momentum of second particle, PA plus PB. Linear momentum after the collision, so PA dash plus PB dash here. So linear momentum of system after collision is equal to linear momentum of system before collision. So this is a 5 marks derivation. Okay, so example in question ಕೇಳ್ತಾರೆ ನಿಮ್ಗೆ, state the law of conservation of linear momentum and prove it in case of collision of two bodies. So again ಬರಿಬೇಕಾ, was a statement of conservation linear momentum. The linear momentum of an isolated system. See the word, it is a system, not a particle. System ಅಂದರೆ ಏನ್ರಿ, ಪೂರಾ ಒಂದು ಸಿಸ್ಟಮ್ ಇರ್ತದ, ಅದರಲ್ಲಿ ಸಾಕಷ್ಟು ಪಾರ್ಟಿಕಲ್ಸ್ ಇರ್ತಾವ. ಓಕೆ, the linear momentum of an isolated system is always constant. ಕಂಡೀಷನ್ ಅದ, ಯಾವಾಗ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರ್ಲಿಕ್ಕಾದೇನೋ. ಕಂಡೀಷನ್ ಅಂದರೆ ಇಫ್ ನೋ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್ ಆ್ಯಕ್ಟ್ ಆನ್ ದ್ಯಾಟ್ ಸಿಸ್ಟಮ್. ಆ ಸಿಸ್ಟಮ್ ಮೇಲೆ ಹೊರಗಿಂದ ಫೋರ್ಸ್ ಯಾವುದೂ ಅಪ್ಲೈ ಆಗಲಿಲ್ಲ ಅಂದರೆ ಆ ಸಿಸ್ಟಮ್ದು ಒಳಗಡೆ ಲೀನಿಯರ್ ಮೊಮೆಂಟಮ್ ಯಾವಾಗಲೂ ಕಾನ್ಸರ್ವ್ ಇರ್ತದ, ಕಾನ್ಸ್ಟೆಂಟ್ ಇರ್ತದ. ಸೊ ದಿಸ್ ಇಸ್ ದ ಸ್ಟೇಟ್ಮೆಂಟ್. ಓಕೆ, ಆ್ಯಂಡ್ ವಿ ಶುಡ್ ಪ್ರೂವ್ ಇಟ್ ಇನ್ ಕೇಸ್ ಆಫ್ collision of two bodies. In case of collision of two bodies. Okay, I have taken the two bodies, A body and B body. A body is moving with velocity u1, so its linear momentum is PA. B body is moving with the velocity u2, its linear momentum is PB. Clear? Okay, and we assume the speed of A is greater than the speed of B, so that there occurs collision. A ಗೆ B ಮುಂದೆ ಹೊಂಟದೆ ರೀ, A ಹಿಂದೆ ಬರ್ಲಾತದ, A ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಅದ. ಸೊ ಹಂಗೆ ಮುಂದೆ ಹೋಗಿ ಎಲ್ಲೋ ಒಂದು ಕಡೆ ಇದು ಕೊಲೈಡ್ ಆಗೇ ಆಗ್ತದೆ ಡೆಫಿನೆಟ್ಲಿ. Okay, so the change in okay, so this is, and during the collision and after the collision it changed its velocity to v1 and its velocity to v2. u1 u2 ಇದ್ದಿದ್ದು v1 v2 ಆಗಿ ಚೇಂಜ್ ಆದವು. So the linear momentum changes from PA to PA dash, PB to PB dash. Clear? Okay, so the change in linear momentum of a body is, ಹೆಂಗೆ ಮಾಡ್ತೀವಿ change linear momentum? Final linear momentum of the body minus initial linear momentum of the body. Final ಯಾವುದಿಲ್ಲ after the collision, PA dash minus PA is a linear momentum, change in linear momentum of body A. Similarly, changing linear momentum of a body B is final of B minus initial of B. Delta PB is equal to PB dash minus PB. Okay, final minus initial. Okay, and then as per Newton's second law of motion, F is equal to rate of change of linear momentum. So we want to write the force equation for body A. A body ಹಿಂಗೆ ಬರತ್ತದ, B body ಡಿಕ್ ಹೊಡಿದ್ರಿ. ಇಲ್ಲಿ ಕೊಲೈಡ್ ಆಗಬೇಕಾದ್ರೆ the force experienced by the body A is the force on body A by the B is equal to change in linear momentum of A divided by the time interval. So that is change in linear momentum is PA dash after collision minus before collision divided by time. In the same way, the force experienced by the B ಮೇಲೆ ಎಷ್ಟು ಫೋರ್ಸ್ ಬೀಳುತ್ತೋ, so that is delta PB by delta T. Delta PB means final linear momentum of B body minus initial linear momentum of B body after the collision, before the collision divided by delta T. And according to Newton's third law, so during the collision, so there will be action and reaction. There will be action and reaction. ಇದು ಇದ್ರ ಮೇಲೆ ಎಷ್ಟು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡತ್ತದನೋ ಇದು ಕೂಡ ಇದ್ರ ಮೇಲೆ ಅಷ್ಟೇ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತಿರೋದ. ಬಟ್ ಇದೊಂದು ಡೈರೆಕ್ಷನ್ ಬೇರೆ, ಇದೊಂದು ಡೈರೆಕ್ಷನ್ ಬೇರೆ. ಸೊ ದ್ಯಾಟ್ಸ್ ವೈ ಆ್ಯಕ್ಷನ್ ಆ್ಯಂಡ್ ರಿಯಾಕ್ಷನ್ ದೇ ಆರ್ ಈಕ್ವಲ್ ಇನ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆ್ಯಂಡ್ ಅಪೋಸಿಟ್ ಇನ್ ಡೈರೆಕ್ಷನ್. ಟು ಶೋ to say the directions are opposite, we are using the negative sign. F of AB is equal to minus F of BA, and be aware about their notations, vector notations. Okay, so PA dash minus PA is equal to minus of PB dash minus PB, and delta T can cancel, and PA dash minus PA is equal to PB dash minus PB dash and minus of minus plus PB. So PA dash plus PA dash is equal to PA plus PB. So this is the linear momentum of the system after the collision, linear momentum of the system before the collision. Okay, so this is about the law of conservation of linear momentum.